Hey everyone, welcome back to Code in Motion. Today we're looking at LeetCode problem number 124, binary tree maximum path sum. This is a LeetCode hard, so it's pretty difficult to try to understand and get this right on your first try. It's really good to break down the problem and truly understand it before you code out the solution. So hopefully I could help with that. With that being said, let's get started with the problem. A path in a binary tree is a sequence of nodes where each pair of adjacent nodes in the sequence has an edge connecting them. A node can only appear in the sequence at most once. Note that the path does not need to pass through the root. That is pretty important. The path sum of a path is the sum of the node's value in the path. So given the root of a binary tree, return the maximum path sum of any non-empty path. It's easier to see this with an example, so let's look at the diagram over here. Example 1, we have 1, 2, 3. 1, 2, 3 is actually a path at the root node. We could connect to both 2 and 3, and so the maximum path sum is 6 in this case. You just sum up all the nodes. However, the maximum path does not need to go through the root node. So in this case, we have -10, for example, but the maximum path sum is 42. It actually happens at 20, 15, and 7. So before we start with the main algorithm, I just want to go over a conceptual overview with a couple of different edge cases and examples so you can truly understand what the algorithm is going to do. Let's look at the first example. In this case, we have nodes 8, 5, 3, and 6, and the maximum path is 19. You take 8, 5, and 6. Now the question I want to ask ourselves is, from nodes 5 perspective, how did I know to choose node 6 instead of node 3, right? Why didn't I choose path 8, 5, 3? How did I know that path 8, 5, 6 is greater than 8, 5, 3? Well, it's because we're going to keep track of left max path values and right max path values at every single node. And so if we take a look at what that looks like from 5's perspective, the left max path is 3 from node 3. The right max path is 6. And so in this case, what is the maximum path at node 5? Well, it's actually 11. We're going to choose to take the left max path or the right max path, right? And then we're going to add the current node's value to it. So in this case, my right max path is greater than the left max path. So I take 6, and my current value is 5. So the maximum path at 5 is 11. I'm going to take 5 and 6. Now we're not going to take both the left path and the right path because we're not going to treat 5 as if it's the root node right now. We're just looking at a path that you could continuously add nodes to. So in this case, we have to choose one branch. We can't take both. So that's the first lesson. We need to keep track of the left and right max path for every single node. Now let's take a look at another example. So in this case, we have 8, 5, -3, and -6. The maximum path sum we can make in this example is 13. You take nodes 8 and 5, which is 13. The lesson learned here is you don't want to take any negative maximum paths, right? Why didn't I take -3 or -6? Well, it's because 5 minus 3 is 2, 5 minus 6 is -1. But if I just take the node 5, I have a sum of 5, which is greater than taking a negative value. And so the lesson learned over here is that we're not only going to take the left maximum path for the left and right sides, but if we see that the maximum paths are negative, we're actually going to choose just to take 0 instead. It's better not to take a negative path because we're always going to be reducing our sum when we really want the maximum sum, right? And so in this case, the left and right max paths are 0. And so the max path at 5 is just 5. We just take the node itself. Now let's take a look at another example. So in this case, we have 8, 5, 3, -6, and 10. The maximum path here is 17. And over here from 5's perspective, we're taking the path -6, 10. But why? I just told you that you shouldn't take a negative path, right? In this case, taking -6 is not a negative max path. In fact, we're taking -6 plus 10, which is 4. Right? So it's not that we don't take negative values, it's that we don't take negative paths. Okay, negative paths. So in this case, it's actually best for us to take -6 and 10 because that's +4. And now 5 plus 4 is 9. And so that's how we get the max path. at 5. Now, in the last example over here is what do we do in the case where it's not beneficial to take the root node? In this case, the maximum sum is 5 plus 3 plus 6, right? And so we're going to have to keep track of the maximum path as if the current node was the root. So this gives us the benefit of taking the left and right max paths, not just one of them. And so what this means for us in the algorithm is that we're going to need to keep track of two maximum values. One of the maximum values is the max path at this current node, but we also need to keep track of a global maximum sum where we can consider the current node as if it were a root node. And we'll see how that looks in the real algorithm. All right, so let's start the main algorithm. I have a global max sum counter at the top over there in blue that we initialized to -infinity. And now we're going to start by scanning the node -10. And we need to calculate the left max path sum, right? So now I'm going to scan node 9. Once again, we need to calculate the left max path for node 9. So now we go to -3. And again, we need to calculate the left max path for -3. Now we hit null. This is our first base case. The maximum path sum for a null node is just 0, right? This is the base case. You have nothing to add. So the left max path at -3 is the maximum between 0 and 0. Remember that we don't want to use any negative values for the left and right max paths, and that's why we take the maximum between 0 and whatever number we saw. In this case, it was 0. So this is just going to be 0 for left max path, and then we do the right max path for -3 as well. Once again, this is the base case of null, so we return back 0, and we take the maximum of 0 and 0 for the right max path sum. Now, remember I said that we're keeping track of two max path values here. For the global maximum sum, the result, we have to treat each node as if it's the root. So I'm going to call this the max if the node is the root, right? If this current node we're scanning is the root. This is going to be the node value plus the left max path plus the right max path. In this case, we're allowed to take both branches. We're going to treat every node in the tree as if it could be the root as well. And so in this case, this sums up to -3. Is -3 greater than -infinity? It is. So we're going to update the maximum sum as well. So let's update that to -3. And now let's calculate the current maximum path sum at -3. Is going to be the maximum path that we return back to node 9. So node 9 knows that it could connect itself to -3. So this is going to be node.value plus the maximum between the left and right max paths. In this case, this is -3 since they're both 0. This maximum path will go to node 9 as the left maximum path. But remember we said, should we ever take a negative maximum path? Never, because it's going to reduce the sum, right? So in this case, the maximum between -3 and 0 is 0. So for node 9, the left max path is going to be 0. We're not going to take a -3. It's not beneficial. Now at node 9, we calculate the right max path. In this case, it's the null base case, which is 0. So the right max path is going to be 0 at node 9. Now at node 9, I have to treat it as this is the root node. So max, if node is root, is the node.value plus the left and right max path sum. In this case, it's just 9 plus 0. Is 9 greater than the max sum, which is -3? It is. So let's update the max sum to 9. We now found a better path to use. We shouldn't use -3, we should use 9. Now we need to calculate the current maximum path for node 9. This is going to be 9 plus the maximum between the left and right paths, which is 0, so just 9. Now, the left max path for node -10 is the maximum between 9 and 0. In this case, it's beneficial for us to take the node 9 because it has a positive sum associated with it. So we're going to use 9 for the left max path for -10. Now at -10, we need to calculate the right max path, right? So now we go to the right section of the tree, which is node 20. At node 20, we need to find the left max path. So we go to node 15, and at 15, we need to find the left max path. So we're going to go to null, and we hit the base case of 0. Now that we're at 0, the left max path is going to be 0 for 15. We calculate the right max path. Once again, we hit the null base case. This is going to be 0, so the right max path is 0 for node 15. Now at node 15, we have to treat it as if it's the root node to calculate the global max sum. This is going to be 15 plus 0, which is 15. 15 is greater than 9, which is my current max sum, so update the maximum sum. Let's use 15 instead. And now we calculate the current maximum path sum at node 15. It's going to be 15 plus the maximum between the left and right max path, which is just 0. All right, so now we go back to 20. The left max path sum is the maximum between 15 and 0. In this case, let's take 15. It's beneficial for us to take 15. Now we calculate the right max path. So we go to node 7, and then at node 7, we calculate the left and right max paths. So this is going to be 0 on each side. Let's just fill that in over there. So we did the left. Now we're going to do the right. We're going to go to the null base case. The path sum is 0. And then the right max path at node 7 is 0. Now we treat node 7 as if it could be the root node. So we're going to add it with the left and right max paths. In this case, it's 7. 7 is not greater than 15, so we don't update the max sum. 15 is greater. Now we calculate the current max path, which is 7. This current max path goes back to node 20 as the right maximum path, right? So now we have a left max path of 15 and a right max path at 20. So now we're going to treat 20 as if it could be the root node. This is going to be 20 plus the left and right max paths. So 20 plus 15 plus 7, which is 42. 42 is greater than 15. So let's update the maximum sum to 42. Now we need to calculate the current max path for node 20. This is going to be 20 plus the maximum between 15 and 7. In this case, we're going to choose 15. So 20 plus 15 is 35. Remember, we can't return back 42 to the negative 10 node because 42 treated 20 as if it could be the root, right? But if we include that to negative 10 or we pass that to negative 10, that means negative 10 cannot attach to 20 because we treated 20 as if it could be the root node. So now we're going to return back 35 to negative 10 as the right max path. Okay, now at negative 10, we're going to treat negative 10 as if it could be the root node. So this is going to be negative 10 plus the left max path plus the right max path. So effectively, we're summing negative 10, 9, 20, and 15, which is 34. 34 is less than 42, so we don't update the maximum sum. Now we calculate the current max path for the root node, negative 10, which is 25. In this case, the maximum you could get is if you took negative 10 and then 35, the right max path. So negative 10, 20, and 15. And now we're done. The maximum sum is 42. It's the nodes 20, 15, and 7. And this algorithm runs in O of n time and O of n space. O of n time because we iterate through every node once, and O of n space because of the recursive stack. If this was a skewed tree, we would have n recursive calls on our stack. All right, so let's start writing out the algorithm. First, I'm going to define my variables. So the way we're going to keep track of the global max sum is by attaching it to the class. So self.maxSum is equal to float negative infinity. We're going to initialize this. And I'm going to define a helper function to do the traversal. So in this case, helper, and I'm going to pass in the root node. And then I'm going to return the self.maxSum. So the idea is the helper function is going to update the maximum sum at every iteration. So let's define that helper method now. So it's going to take in a node. What's our base case? If the node is null, so if not node, then return 0. This was the base case. Now I need to calculate the left max path. And the left max path is helper node.left. However, we said that we never want to include a negative maximum path, right? So in this case, I'm going to take the maximum between that result and 0, just to ensure that the minimum value of this is 0. We're never going to include negative max path values. The right max path is the maximum between helper node.right and 0. Now I need to calculate the maximum if this node is able to be treated as a root node. So max if node is root is equal to the node.value plus left max path plus right max path. Now self.maxSum, so my global maximum counter is the maximum between the current maxsum and max if node is root. Now, what is the current maximum path that I return back? It's the no.value plus the maximum between the left max path and the right max path. And that is the algorithm. Let's verify that it works. And there we have it. Thank you so much for watching. If you're interested in more content like this, be sure to subscribe and like the video down below. It means a lot. I'll see you in the next one.